we will focus on your confidence intervals. And then study unit 9, we will focus on hypothesis testing. So it really goes nice together. So the things that, and even before we go into, let's quickly just do a quick sketch of the things that we will look at. So confidence intervals, basically, we're going to look at three different ones. So the first one is where your standard deviation is known. Then we're going to use a Z. Then standard deviation unknown. We're going to use a T. And then when we get to proportions, we go back to the Z again. Okay, so that is on confidence intervals. And remember, it's always nearly there's a lower and there's an upper confidence interval. Then we will go to hypothesis testing, where it's the null hypothesis and alternative hypothesis. And again, there we would have it where the standard deviation is known. We can have it where standard deviation is unknown. And then we can also have where we look at the proportions. Okay, so that's why I thought let's do these two together, because in most instances we'll use the same formulas. So let's get into it. Okay, so first few will be on confidence intervals, and then the next few will be on hypothesis testing. Okay, so Department of Basic Education, and let's just, I want to just crop this a bit so that, ooh, crop a bit, and hopefully we'll have a bit more space that we can write on. Okay, cool. Okay, so we look at the information from a survey of 150 learners. Okay, so we've got N is 150, but the first thing I really want to know is the standard deviation, is it known or unknown? Learners suggest an average travel time of 114 minutes. Assume the population standard deviation, so not sample, population. So because it's population, the population standard deviation is known, and it is 72 minutes. Okay, so cool, have that one. So then let's go to our formulas. So we need to have x plus minus z times standard deviation divided by n. Okay, so because we know standard deviation, we know then the z can take three numbers for you in the exam. Can have when it's 90%, when it is 95%, and when it is 99%. Okay, so you don't need to worry about any other ones in the exam. That is for free, that you need to know. It is in the study guide. So I see we need to work with 95. 95 is 1,96. So let's see if we can get all the information. We've got the average time is 114. We've got the Z of 1,96. And when we multiply standard deviation was 72. And that divided by the square root of 150. Okay, so this number is not going to be a clean number, so we'll definitely can already see it's going to be some decimals, so all of them can be options. Another one that I just normally check is, remember, confidence interval. So we'll have a bottom one. In the middle will sit 114, and then we will have a top one. So you guys can always just afterwards check if you can add those two together, and it gives you 114. If you divide it by 2, then all of them is possible options. That's just sometimes something that I will check. If you add those two together, divide by 2, you must get 114. Okay, so already here you might see 114, so times 2 will give you 228. So if you add those two, it might give you 228. Okay, so let's go into this. So 72 divided by the square root of 150, which is 5,8788 times 1.96, gives you 11.5224. If we multiply that by 1,96, I get that we're going to add and plus 22. And now I'm worried that I made a mistake, so I'm going to redo this just. This looks very big. So let me quickly just recheck. 72 divided by over square root of 150. I think I used 50. No, it gives me 5.8788 times 1.96. Okay, that's where I made a mistake. So this is 11.522. Okay, and then we can check. We add 114 to it. One can get 125.52. And if we subtract 11.552 from 114, we get 102.48. Let's see, there's option B. And just to check, if you add those two together, 102.48 plus 125.52, and you divide it by 2, you will get 114 as well. Okay, so that is the first one, but what I will always check first, standard deviation, is it known or unknown? Then the next thing is to look at the Z. So if you know it's known, then we can go into the Z. the Z can only be a 95, a 90, and a 99%. So you can then work around those. Okay, so let's look at another example, and let's see what's available, what they give you. A household survey based on a sample of 50 households in a rural village found that the average household income to be 3,500 with a standard deviation of 1,000. Construct the 99% confidence interval estimate for the population mean household income and choose the correct answer from the list of options. Okay, so first of all, is standard deviation known or unknown? Is the population standard deviation known or unknown? That's the first thing that we need to look at. What would you guys have set in this instance? Standard deviation, and you can just put something in the chat. Standard deviation known or unknown? And we've got one that says known. Okay, two says known. Okay, everyone is go for known. Okay, so let's go with that. I'm wondering. So let's go with that. So let's go with known. 99%. Ooh, I think that is 2,58, but let's quickly check in your study guide. I just quickly want to open that. I'm sure it is 2,58, but let me just 100% sure to check if this is the right one. No. Quickly check that was somewhere study unit. Particularly study unit 7 or 8, where that table was. Okay, so 99%, 2,58, yes. Okay, so Z gonna be, okay, cool. Okay, so X is, what's the average? 3,500. Okay, so if you just quickly check, sounds like that, or it looks like that will add up to 7,000 divided by 2. So most of them looks like 3,500 will fall in the middle. 2,58. Standard deviation, 1,000. And then your sample size, 50. So that also looks like going to be a big number. So 1,000 divided by square root of 50. I get 141.42. We're going to round it also off to two decimals. So that times 2.58 and rounding off to two decimals. 364.87. Just check for me if that is what you get as well. So 1,000 divided by square root of 50, 141.42 times 2.58. Okay, so if we do this, your top answer will be 3864.87. Your bottom answer will be 3135.13. Okay, and you have the answer for that. Okay, so if you went for standard deviation is known, there's answer. Okay, so let's just quickly check again. Where in the question did they tell us it's known? Where in the question do they tell us that the standard deviation that we know is a population standard deviation? And that for me is important because this will happen in the exam as well. So let's check what do they tell us. A household survey based on a sample of 50 found that the average household income is that. Now let's go back to that previous question. Here they also said there's 150 learners. Average time, assume population standard deviation. Okay. In here, nowhere did they tell us what that we assume. So we are going to construct, and then we hope that the estimate is around the population mean. Okay, so nowhere did they tell us here that we're actually working with a standard or population standard deviation. Okay, so that is for, and that's why it's so important, because there is an answer for us. So in the exam, that is why this is so important. So let's rather make the mistake now while we're practicing, because it is very easy to make this mistake. Okay, so let's let me undo this. Let's just do this. That gonna make a cross through it, but let's duplicate so that you can just in any case also just work with it. Okay, so let's now go through it again, and okay, so that will still stand. There will come in a difference, which will make that different. which will make this different. Okay. So let's so we have a sample. So the sample standard deviation is 1,000. The sample is 50. So this actually didn't matter what we were looking at. This stayed the same. Okay. Big difference that's coming in is the t. So our z was 2,58. So let's see how big a difference does that bring into a calculation. So let me see, where is our t table? Okay, this is t table that we're going to work with, and let's see what we need. So t is degrees of freedom, and then alpha divided by 2. Degrees of freedom, remember, is n minus 1. So let's put in the alpha is 0,01 divided by 2. So we're going to look for a t that is 50 minus 1, 49. And let's just see what is 0.01 divided by 2, 0.005. Okay, so let's see how big a difference that makes. There's degrees of freedom 49. Okay, so it's just on the next page. Okay, so there we have 49 and 0,005. Okay, so we're going to work with 2,68. Okay, so sure, just a bit. So it's not even that big a difference. 2.58, 2.68. So let's just see if this actually now works out. So 1,000 divided by square root of 50. It's still the 141.42 times 2.68. So we're now looking at around 379.01. Okay, so 3,500 plus 379.01 is 3,879.01. 38. Okay, so there at least is one of them. Okay, so let's just check the bottom one. 3120.99, which is then option A. Okay, so this, I wanted, that's why I also went through to show you guys, if we followed the standard deviation is known, there is an answer, which is the scary thing. So standard deviation unknown because they don't give us the population standard deviation. So always just check when you get around the standard deviation, is there something that they talk about it? So what will normally happen? Yeah, But um, but but with that catching out, you guys will definitely now not be caught out in the exam. So yeah, please look for that it needs to say population standard deviation. And important nearly for this is in the exam, you will most likely get all three of them, or at least two at each of those study units. Um, so yeah, don't get caught out, especially with the Z and the T. Okay, so then they gave this one from one of the study of I think it was one of the assignments um, that I saw. But last year they actually gave something like this in the exam as well. And remember, don't worry after the exam if somebody else gets a different answer to yours, because what they did last year was, for one, because again there's random generated the questions. For somebody, it might be 27 degrees of freedom. For somebody, it might be 29 degrees of freedom. And for somebody, it might be something different. Okay, so they said consider T distribution with 27 degrees of freedom. Which one of the following statements is incorrect? Okay, so let's go to this T distribution. Okay, see, so there was definitely another question that at some point covered 29. We have 27. I just want to see why it doesn't now want to underline that. So let's rather then go with highlight again. Okay, so 27 is this line that we basically will work with. Okay, so the t-value associated with a lower tail probability of 0.01. Okay, so let's just go up 0.01. You can go down 2.4727. So if it is on the lower side, it will just be negative, so 0.473. Okay, so that is correct. We're looking for the incorrect one. Okay, so again, let's just quickly check. Minus 2.473. It was 2.473, but because we're asking lower, lower is on this side. So just like the Z distribution, you can have at that side is the upper, and on the left-hand side is the lower one. Okay, so let's go to the next question. 95% of the area under this T distribution falls between those two. Okay. Now what we need to look at is, again, like the Z, and I now want to get something. It is not that one. Let's do that. Okay, so like Z, you will have the 95 in between the two areas. Okay, so your 95% will lie between the negative and the positive t. Okay, so for it then to lie between this, it needs to be alpha divided by 2, like we do in all those calculations. So if we look at the 5%, 5% divided by 2, and this we can really make a different color. Okay, so 5% divided by 2 is going to give you, and let's quickly check, 0.05 divided by 2, 0.025. Okay, so we can check here 0.025. The answer then should be plus and minus 2.052. 2.052. Okay, we see it's not that. That is probably for a full 5%. So let's just look. So if you went for, okay, actually not the full 5%, where is 2.771? Okay, so if you went for 0.005, there was an answer for you. Okay, so option B is the incorrect one, which we are looking for. But let's just check all the others as well. I think it's important that we just check. The t-value associated again with a lower tail, 0.025. Well, 0.025, that is what we just had. So it will be 2.052, but negative, so negative 2.052, which is correct. Okay, then in B we said 95%. Now we want 90%. Okay, so 90% that falls within. So what falls without it is 10%. 10% divided by 2, 0.05. Okay, so 0.05 will be plus or minus 1.703, plus minus 1.703. Okay, so that also correct. Then we go to 80%. 80% in the middle, so what's left outside of that is 20%. So 20 divided by 2 will give you the 10%, which is 0.1. 0.1 plus minus 1.34. Plus minus 1.34. Okay, so that is how you can just look at the t-table and get questions around that. They can go up to 0.25, so up to 75% that needs to be in the middle, and they can go as far as the alpha, that is 0.005. Okay, so that's where they can stop it. There's, again, they won't be able to ask you what is 60% of the area under the t distribution, because again, you can't get it from the table. So if it's not on the table, you won't need to be able to get those numbers. Okay, but this is nearly looking at the t distribution or the t table and using that t table. Okay, so reason why we divide by 2 is the t and the z is very similar. So And you can look at it from a confidence interval point of view, always an upper, always a lower. So if here is 90%, then what is left is this part and this part, and they are both together equal to 10, because 10 plus the 90 gives you the total 100. So if I just want one of those areas, I need to divide by 2, so that I can say 5% is this component here will be 5%, and that component there will be 5%. Okay, so that is why we divide by 2, is because we assume it's a normal distribution. Underneath a curve, it's 100%. Then whatever is in the middle, the other two tails. And that's why also when we work with confidence interval, it will always be a two-tail. Okay, so, but they will never really talk about the two-tail in a confidence interval question, but confidence interval is always a lower and always a upper. Okay. So let's look at what we have here. So again, let's see if it is Z or T. Is it known, or is it a sample that it is unknown? So let's see in the wording. Simple random sample of 46 from a normal population results in a sample mean of 300. Okay, so at least we've got that already. We're going to have a sample size of 49 and a sample standard deviation of 50. Okay, sample standard deviation basically means that we're working with a T. Okay, so unfortunately, T, you need to go to the table. So what can happen is if you set it a Z where it's known, you go to 90. If it was Z, you would have said it's 1,645. Okay, because that is what is in, I say 1,645 is the 90. But let's quickly see now from degrees of freedom, or if we go, sorry, let's just take a step back. The T, degrees of freedom, and alpha divided by 2. So degrees of freedom is n minus 1. So we set with 45. Alpha divided by 2. So 10% divided by 2 is 5%. So it's 0,05. So 45 and 0,05. 45, 0,05. 45, 45. Sorry, I thought it was other one. Okay, so 45. And let's just make sure 0,05. Okay, so it's very close. So 1,6794. 1,6794. 94. So very close to 1,645. So you will also see, if we look at these answers, there's a 280.61, 280.11, 277, 287. So very close to one another. This one is probably the one that is going to be wrong. But again, because the Z and the T is so close to one another, um, it it can be that if you make a mistake by using the one, you can get the other answer. Okay, so 50 divided by square root of 46, 7.3731. 300 plus minus that. So just again want to check my answer, but it's 12.38. Let's just see. They keep it at 2 decimals. So I'm going to keep it at 2 decimals as well. So the top level, 312.38. Ooh, 310, sure. 312.38. And if I to 75.24. Okay, no, I now made a mistake. I think I double subtracted here. So 300 minus 12.38, 287, 287.62. Okay, so let's quickly, so there is your answer. Okay, so very important that, again, identify if it's known or unknown, um, so that you can use the correct one, because you can see again, the Z would have been incorrect, but very close to what the T is. And I assume if you used that, you might, or you might even get that it doesn't fit any of the answers. Um, yeah, okay. So we're supposed to have one more with, I should have had, so let me just write it down. We need to get a proportion one. So I will add that to one of our next sessions that we will still have before you write exam. So a random sample of size 100 results in a sample mean of 100. The population standard deviation is known to be 15. Important population standard deviation. What is the margin of error for estimating the 99% confidence interval? Okay. No. Okay. Yeah, so I've just read the chat. You don't need to. What I normally always do is show it your calculator, show it your. I normally do it just so that it doesn't. But you actually don't. You don't need to show your your notes that you printed or anything like that. But I do sometimes, and another tip that I normally do is whenever there's something that if you at home gonna write it and there's some noise, actually tell it. Tell it, mom or grandma or somebody's in the kitchen shouting or um, just that it, because what it's going to do in the exam is it picks up noise. So if there's something strange, it's not, it will flag it, and then it will be that after the exam, they will go through that whole recording. So if something you actually, while you're writing, you say, um, hear that it's a bus going by, or it's some just it's one of those things that you don't want the nearly the computer to let you guess. And it is, that's why I say normally I never showed all my notes because, again, you print nearly everything, and then it becomes chaos. So just say something if you want to, but it is not needed. Okay, let's go into this one again. Error of estimating, margin of error. Okay, so how many study units ago? Two or three. We did the standard error. Okay, so remember standard error was this. Your standard deviation divided by square root of a sample. Okay, so let's do that and let's just see. Hopefully there's not the answer because we're actually not working out the standard error. So let's, population standard deviation was 15, sample is 100, so the square root of a sample is 10. Okay, so that would have been 1.5. Okay, so luckily there is not a 1.5 here. So what the margin of error is, so if we have this formula, the margin of error is that component that you add or minus from your mean. Okay, so 99% confidence interval is 2,58 times that 1.5 that we now have. So it is basically your Z times your standard error. Okay, so 2,58 times 1.5 gives you 3,87. Oi, okay, 3,87, 3,87. Like I said in my exam, something like this happens, you let me know because it's either B or C, B or E, both of them are correct. Okay, very important in this question again, population standard deviation. Else, it would have been a T times that standard error. Okay, I assume this, let's just look at, I assume it would not have been our option, but let's just check. So 1% divided by 2 again would be 0,05. They talked about a sample of 100, so 99. I see, so it's very close in any case. 2,6, 2,6264. Let's just see if we had 2,6264 times 1,5. It already if I look at that, there's not going to be at least be an answer for us. I say it would have been 3,94. So it might, your, okay, so it would have been 3,94. So, yeah, so luckily we did not need to worry here about the T because that have been when it was unknown. Okay, so just remember, if you need to work out the margin of error, you can actually also get a question where it is about the sample standard deviation. It does not need to be the population because you can work out it with the T. The same with the population proportions. So just remember it is also available for proportions. So let's just go to that component. So it could have been that this margin of error was also this. Let's just put this piece in so that you know when you go through it, it could have also just been that you needed to look at this if it's a proportion. Okay, so if it's a proportion, this again is the margin of error. Okay, so that is confidence intervals that we looked at, and confidence intervals nearly nicely go into your hypothesis testing. Important with hypothesis testing is, again, where for the zero or the null hypothesis, the alternative, if you have the equal, that is the only time where it is a two-tail. And so equal will give you two-tail. All the others, if it is bigger or equal to, smaller or equal to, those four will give you a one-tail. Okay, so that is the important thing about hypothesis testing. All your confidence intervals was always two-tail because we always looked at lower confidence, upper confidence, but when we're working with hypothesis testing, it can be a one-tail. So what I normally would do, okay, let's just quickly, just want to quickly move things around so that one I'll move to our next session. I quickly want to move those to in front just to show you guys. Okay, so what I always look at is if you look at the null hypothesis, alternative hypothesis, you can nearly already say, is it a one-tail or two-tail? So you can see smaller, that one is bigger, so it's going one direction. So this will be a one-tail. And I've included a bit on that in each slide. But again, you can see here always to a one direction. So again, it will be a one tail. And is there one that, so yeah, again, one tail, even if it's not asked, it is important when we do get the results because it might mean it's a one tail that is sitting here, which you then don't need to multiply by 2. But if you have a two tail, you will always multiply it by 2. Okay, like we've seen in the confidence intervals, we always divide it by 2 because we wanted to get the other areas. Okay, so let's just see if there was. Okay, this is a strange one. Oof, okay, and there's. So again, if you see something like this in the exam, null hypothesis, both are null hypothesis. So what must you take out of this? So we'll do it one way, but again, something like this, if this happens in the exam, you automatically, if this was question 12, after the exam, so you remember it's open book, so you can write down, after the exam, you just let me know, Jean, question 12, I think there was an error, so that we just let the lecturer know even beforehand, before it even goes into the marking system. Okay, so let's look at a question like this. So in a sample of 36, the sample mean is 86. It is also known that the population standard deviation is 16. Okay, so that tells me, at least working with a Z, you are required to use the information to test the following hypothesis. Okay, so let's look at, and they ask us which one is incorrect. Okay, null hypothesis, mean is bigger or equal to 80. Okay, so not equal. So let's first work out what is the Z going to be. So now we use, sure, way back study unit 7. Was X, they told us the sample mean is 86. We're testing it against 80. Did they tell us the standard deviation was 16? And they said to us the sample is 36. Okay, so that is going to be somewhere positive. So 86 minus 80 gives us 6 at the top. So I'm just going to quickly go on this side. And below 16 divided by 6, because 36 will be that. It's 2,667. So if I say 6 divided by that, I get a t value, a z value of 2,25. And let's just quickly move that when it is shared. Okay, 2,25. So we're going to check. Here is going to be 2,25. We're going to check if it is, they told us, bigger than that. So already you can see we're working with a one tail. That one tail is an upper tail because it is positive. If it was negative, it would have been what is lower tail. And I wanted to think what's the opposite of upper. Lower tail. So lower tail would have been a negative. So we're working with a upper tail. Correct. They could have said upper one tail, but because it is just going to go to the one side, upper tail is fine to ask in the question. We worked it out. The test statistic was 2,25. So actually we have worked that out. So now it comes that we need to say if we reject or not. But before that, let's work out what is this p-value. So the p-value, and so the p-value, we're looking at 2,25. So where is that? So now we go back to our z's. I want this area. So again, to go now to 2,25 and say 1 minus that, just going to make that I might make an error. So I want that area minus 2,25, and we sit with 0,0122. Okay, so our p-value is 0,0122, 0,0122. Okay, correct. If it was two-tail, we would have just multiplied that by 2 because then we wanted to have the size of the other tail. Okay, so one tail, we only take that one side, so that will be our p-value. If it was two tails, if it was equal and not equal, we would have needed to add the lower tail component as well, and that would have just been 0,0122 times 2. Okay, so then basically we need to make a conclusion. Okay, so we worked it out as our z is 2,25. So they say at a 1% level of significance, the rule is to reject the null hypothesis if the p-value is greater than or equals to that. Okay, so that is going to be the incorrect one. You reject the null hypothesis if a p-value is smaller or equal to 0,01. So that is the wording that was wrong. Okay, so that's why I added it here. If a p-value is smaller or equal to, you reject the null hypothesis. Okay, so here it could have been two things in the mix. So reject when it's smaller or equal to, or if it is greater than, you would have said accept it or do not reject. Okay, so do not would have been greater or. Okay, so that is nearly the one that is wrong here is or it should be smaller than, not greater, or you would have needed to say if greater was correct, it would have needed to say do not. Okay, so that is, and that's why I've added this. I will also add somewhere bigger copy of this one that you guys can also have access to this note. And then at the 1% level of significance, the null hypothesis is not rejected. And so that again is saying the same as the above. Yeah. Okay, so we're going to do another one of this where again was very similar. So you could see it comes again out of a previous exam where for one group of students, this was the question. Um, Sample mean is 86. Then for another set of students, okay, sample mean is 83. The rest stayed exactly the same. Sample 36, population standard deviation is 16. If you look at that one, the one was bigger. Here, the one is smaller. Okay, so this then automatically tells me that I'm working with a lower tail. Okay, so let's see which one is incorrect. I would have nearly wanted to say that. So we then first need to work out if that 80 makes it a negative or not. Okay, so that is first. So also just don't make assumptions. So let's go Z mean. Okay, 83. It's still bigger, so it will still be positive, but that then is going to be a very big p-value. And we've worked out from a previous one, what was it, 36 divided by 6, what was it, 2,667. I'm just going to steal that one from the previous question, 2,667. So Z is 3, because 83 minus 80, it's 3 divided by 2.667, 1,1249. Okay, test statistic is 1.285. Okay, that's the incorrect one. So it needs to be 1,1249. Okay, so let's draw it. It's positive 1 comma, and let's round it off, 1 comma 1 2, and I round it off to 3 decimals, so let's do that, 1 comma 25. Okay. Okay, so let's see. That will be the p-value. So again, p is lying on the right-hand side. It's positive. So we're working with the upper tail. So just be very careful. I thought because it's going to be smaller or equal to, it is upper tail, but wait, I'm now confusing myself here because it's still smaller than. So we're looking at this side. So here is definitely something wrong in this question. Let me just quickly see if I'm now in this one. We got that because it said bigger or smaller. Here it is smaller or equal to. So now we're looking at this component. So an upper tail is applicable is actually also incorrect, even though it is very high. So I think this was the mistake. That should have been bigger or equal to and not the way it is, because if you look at the p-value, that is going to be a big p-value. That is probably going to be 0.1303, which would have been working if that was bigger or equal to 80. Okay, so I think again, they were probably too clever and tried to make too many changes instead of just making the numbers change. Or they should have said which one is correct. So let's just check the p-value. I would have gone to 1,13, and now I would have used that one, but let's now say it was the other side, minus 1,13, 0,1. Yeah, okay, no, so let's not, this one is really not working out. 1,1. Sorry, I'm also now looking at 1,13, 1,1. There's 2, there's 3, so that's also, let's just see, where's 1,303? Okay, yeah, no, so this, let's just make a big cross for this one. You guys can go and check it again if you want, but so that would also have been wrong for me because that is not 1,1303. So at a 10% level of significance, the rule is to reject the null hypothesis if a test statistic is greater than or equal to 1,285. Okay, see now at a 10% level of significance, null hypothesis is not rejected. See, so with everything now wrong, yeah, so let's keep it in, but go and work it actually out with the question set as being this and not what is given. So go and work it out as this and then see, and also maybe check if it was only correct. Because that already, so 1,2, there's a mistake, there's a mistake, that's a mistake. So it's probably going to be correct, but sure, there's so many mistakes in this. Yeah. Okay, so let's not worry about this question. It's going to be in the recording, but when I share the pack, I'm going to delete this question. Okay, so yeah, not happy that I have not picked this up. Okay, let's quickly, next one. So let's see the information that they give us, and then what do we need to do? So they tell us consider the following hypothesis: small or equal to bigger. So that tells me we're working with one direction. This also is, if you look at that, it's proportions. So let me quickly bring in the formula of proportion for this. The proportion one, it's one of those that I never remember. So the proportion one, I will just copy from this. Cool. So let's go and check this. So want to work out a Z, and then wherever that Z is, it needs to be smaller. Okay, so hopefully it's a negative number, and then we work with, because what I see here, it should be something small that we're working with, but let's just make 100% sure. Okay, so they tell us in a sample of 100, the sample proportion is 0.83. Calculate the p-value for the test and choose the correct answer. Okay. So let's just see. Again, not. That n is 100. So let's quickly see what that comes out to. 0.83 minus 0.75. That already gives me a positive. Not happy with these questions tonight that we're doing on hypothesis, but let's see. Okay, so if I work that component out, 0.0433, okay, scary that that is in one of the answers. I get Z is equal to 1.85. Okay, so that is what I'm getting. Z is equal to 1.85. So again, if we follow that principle, 1.85, let's see what is that value. One tail, 1.85. So 1.85, 1.85, 1.8. 0.0322. 0.0322. I'm still worried, but that is 0.0322 is that side. If it was two tail, let's just quickly see there's not a 0.0644. Okay, I'm still worried that that should have been, if I look at that the other way around, but there is the option of 0.0322. And let's see this one that I also said was not already written correctly. Uh, and obviously, if that is one that is, you're going to look at that option as one side and two-sided. That okay, the others at least doesn't times two give you the other one. Okay, so let's see in a sample of 100, the sample proportion is 0.32. Consider the following hypothesis test to calculate the p-value and choose the correct answer. Okay, so 0.02 minus 0.4, and then let's just copy that proportion formula in. Please tell me if I'm making a mistake somewhere, because this feels to me that I am. Let's 0.03 minus that. So that at least is going to be a negative, minus 0.4. So at the top, minus 0.08. At the bottom, 0.4 times 0.6 is 0.24 divided by 100, 0.0024, square root of that, 0.049. And then if I say that divided by that one, I get minus 1.63. I'm just going to check that again. 0.08 divided by 0.049, minus 1.63. Let's check minus 1.63. Minus 1.63 minus 1.63, 63, 0.0516. Okay, so that is 0.0516. You look at that, it shows that one direction. So that is why we choose the one-sided. That, again, should not have been equal to. That is how it should have looked like. But if we look at that should have been a 1 as well. So this one again, sure, mistake there, mistake there. So hopefully these things does not creep up in the exam. But if there's anything like this in your exam, please let me know, because that is a big thing now that we've seen a few mistakes. So really, please, whenever there is something like this in the exam, please let me know, that we don't end up with you guys losing marks because there was errors in the paper. Okay, so these days they normally go through it a few times, but still things do creep in because of them needing to nearly change questions. So it might be that they looked at this question, were happy that everything is okay, but then the other one might creep in errors. So please, when you write the exam, make notes of if you feel there was questions that you felt was wrong, and it's okay. I'll let the lecturer know, and if it wasn't, then it's also fine. But rather, let's just make sure that um, and I will not tell him that everything is wrong, but yeah, please let me know if there is one or two that you felt could have been that you're not getting the answers, or it might be very close to what you have gotten. That we just make sure that it does not happen in the exam. And normally, what will happen if there was a mistake with a question is that the question will be thrown out